Finally, we take official notes on sigma notation. We've been introducing it this whole chapter, and now we get the real, official word on what sigma means. So sigma is this symbol here, is a capital S in Greek letters, and the sigma notation symbolizes really adding up numbers. Okay, so when we see our sigma notation, it'll look like this. N goes from 1 to 5, and it'll have like a rule like 2n minus 1 or something like that. So each thing has a different thing. So n equals 1 is the number you start with. So you start by plugging in a 1, and then you plug in a 2 and a 3 and a 4, and in this case a 5, the number you end with. You end with the last number. And here is like the rule that you're plugging those numbers into. So for example, if k goes from 1 to 5 of 4k, sometimes I'd like to write down, okay, k is 1, k is 2, k is 3, k is 4, k is 5, and then actually plug those numbers into the rule 4k. So 4 times 1 plus 4 times 2 plus 4 times 3 plus 4 times 4 plus 4 times 5. Now, if it's only 5 numbers, no biggie, right? You can just add those numbers up. Actually, I can just add those up. So what I see, 20, 40, 60, it would all add up to. Easy. But what if instead of going from 1 to 5, it went from 1 to 50? So if it went from 1 to 50, then I'm going to have like a dot, 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 and then I'm going to plug in the last number, let's say, is 50. So if I plug in a 50, I get 200. That's 50 terms. I'm not going to add those up by hand. How would I find the sum of those 50 terms? Right, I would use my formula. Is that arithmetic or geometric? Well, if you look at it, it's adding 4 each time. It's arithmetic. So the formula is n, which is 50 over 2, a sub 1 plus a sub n, or 25 times 204, right? So you would have 25 times 204 is 5/100. Now I have to be careful. Sometimes it's geometric, but we'll get to that. Here's one where it doesn't start with 1. That doesn't happen often, but I wanted to put one in the notes where it starts, in this case, at a 3, 4, 5, 6, 7. There's only 1, 2, 3, 4, 5 terms, so not that big of a deal. You're going to plug in the numbers into the rule, and this is what you get. And if it's only 5 terms, I don't think I need a formula. I can just add those up. Those happen to add up to 65. So again, I was just plugging into the rule, That's how I'm getting those numbers, plugging in for n each time. Okay, this one here starts at a 0, and then now we see, and by the way, back to number 2 for a second. Was that arithmetic or geometric? Right, it was arithmetic. So I want you to look at those rules, 3n plus 2 and 4k, and how do those rules differ from these rules in 3 and 4? What do you notice? Right, 3 and 4 have a variable in the exponent. So 3 and 4 are going to be geometric. When the variable is in the exponent, it's geometric, and you'll see in a second. So if I plug in a 0, a 1, a 2, a 3, a 4, well, 4 to the 0 power, 1. 4 to the first, 4. 4 squared, 16. And then eventually, you might even just, well, I guess that's just 64, and then 4 to the 4th is 256. The thing about geometric is they get so big so fast, so the sums will also get so big so fast, okay? Here, I just, again, only have 5 numbers altogether, so I could just add those up. Those add up to 341. If I wanted to, add them up, let's say instead of a 4, let's say it was, I don't know, a 40 is going to be too much. So let's say it was a 14. Change colors here. Let's say it was a 14, then I would go all the way to j equals 14. This would be plus 4 to the 14th power. Then I would use the geometric sum formula. So the sum of those actual 15 terms, because I started at 0, would be a sub 1 minus a sub 1. What's the r? right, 4 to the n, there was 15 terms altogether, over 1 minus r. Now these turn out to be really big numbers. 1 minus 1 times 4 to the 15th power sometimes, yep, and then divided by -3. So here I would get, I didn't write that top number down, but I would get 3, 5, 7, 9, 1, 3, 9, 4, 1. So we get really big numbers when we add up geometric series. So we tend to keep the number of terms small. So here again, there's only 5 terms, starting at 1, 2, 3, 4, 5. When it's only 5 terms, I'm just going to plug them in. Although these terms, they get pretty big too. 2 times 4 to the 0 power, that would be 2. I'm just doing it in my head. 2 times 4 to the first is 8. 2 times 4 squared is 32. And then after you get a couple, you're like, oh, okay, I see. The common ratio is 4. 2, 4, 8, 32. What's that going to be? 128. And then 128 times 4 is 512. Again, when there's only 5 numbers, I can just add those up. And if I add them up, I get 682. If there was more than 5 numbers, even just a few more, I would go back to the sum formula, S sub n equals a sub 1 r to the n over 1 minus r. Okay. By the way, one other thing about the geometric S sigma ones, the common ratio is always the number being raised to the power. So both of these happen to have an r of 4, but you'll see anytime it's raised to a power in the rule, that base is always the common ratio. Okay, so a couple more examples. Use sigma notation. So this is going backwards, and I'm giving you the hint. Okay, so you don't have to start with 1, but most of the time we do, so I think it's easiest to just say we're going to go here from 1 to 5. You could have equivalent answers that start at a different number, but most often 1 to 5. Now, some people might be able to figure this out in their head, like some kind of rule. I notice a pattern that it's arithmetic. Well, I told you that. I can see that the common difference is 4. To get the rule, I'm going to go back to my original formula, a sub 1 plus the n stays in as a variable times d. So plus 4n minus 4, which is 4n plus 1. And you can check that it works with every term by plugging in a 1, a 2, a 3, a 4, a 5. With the geometric, this is going to go from n equals 1. I'm just going to write 2, 3, 4, 5, 6. So n goes from 1 to 6. N equals 1 to 6. It's geometric. Common ratio looks like -3. So I'm going to use the a sub n, it's n equals a sub 1 r to the n minus 1 geometric formula. So 1 times -3 to the n minus 1. So this is just going to be -3 to the n minus 1. If that was a number, by the way, if the first term was not a 1, that number would not get multiplied by the -3. These neither ones stress people out sometimes because there's no formula. It's not arithmetic, it's not geometric, but I can just look at it, can't you? And say if n goes to 1, it's 1 squared. If n is 2, it's 2 squared. Then it's 3 squared. Then it's 4 squared. Then it's 5 squared. So it must be n squared as the rule. Another neither one. When n is 1, it's 1/2. When n is 2, it's 1/3. When n is 3, n is 4, n is 5. Doesn't matter, the numerator is always 1 and the denominator is always 1 more than the number of term you're on. So 1 plus 1 is 2, 2 plus 1 is 3, and so on. So you don't show work really for the neither ones. You can use formulas for the arithmetic and geometric, and that is sigma notation.